Grade 12 seniors. Today I'm going to explain for you the last lesson in your term 1 required material, and this is lesson number 11, and the title of the lesson is solubility. Solubility means dissolving a solid in a liquid, which is here is going to be water. So I'm going to dissolve a solid in water, and we will measure how much of this solid will dissolve and how much is its solubility. Okay, we have NaCl solid. Okay, and when I take NaCl solid and I dissolve it in water, what happens to the NaCl? The NaCl will simply dissociate and it will give you Na plus ions and Cl minus ions. Okay, now this one is represented as NaCl solid, and this will dissociate into Na aqueous plus Cl aqueous. If you are not sure about the charges, it's okay. I want you just to understand that it will dissociate into two aqueous ions. Usually the first one is the positive ion and the second one is the negative ion. Now this one is said to be a soluble salt. Soluble means it dissolves completely. Now sometimes I have slightly soluble salts. When I say slightly soluble, this means part will dissolve and part will sit down in the bottom. It means that it will not all dissolve. For example, if you have AgCl solid, what happens when AgCl is dissolved in water? You will notice that part of it will dissociate to give you Ag and Cl, and part of it will not dissolve and it will stay here in the bottom of the container. So how do I write this reaction? I say AgCl solid. Now it dissociates into Ag aqueous plus Cl aqueous. But بما إنه not all of it will dissociate, part will be solid in the bottom and part will dissociate, I will put double arrow. Okay, and as you know, Ag will be positive, Cl will be negative. Okay, so this is the difference between soluble and slightly soluble. Soluble means one arrow because it dissolves completely. Now slightly soluble يعني شوي يدوب وشوي ما بيدوب. Okay, so part of it will dissolve and part of it will not dissolve. So here we have double arrow. Now here we have equilibrium again. You remember the previous lesson we were speaking about equilibrium. Okay, now which reaction I can write for it? Constant of equilibrium, which is KAQ. طبعا هون I cannot write KEQ طبعا because there is no equilibrium. I can write KEQ here. So KEQ here in this case will be P over R. The products are Ag and Cl over, طبعا this is a solid, so this will not be counted, so I will say over 1. Be careful, if there are no reactants, I don't put 0, because anything over 0 is undefined. So if this is cancelled, so I put instead of it 1. So the KEQ is equal to Ag darb Cl over 1. Here I will change the name of KEQ. I will call it KSP. Only the name, everything will be the same. Products over reactants. If there are coefficients, you make them powers. If there is solid, you cancel it. Only change the name. Now, what is S? What is P? S means طبعا solubility because I am speaking about soluble compounds. And P means product because these two are multiplied by each other. Okay, so this is called the solubility. Product constant. It follows the same rule of equilibrium, but here we are dissolving salt in water. Okay, so now what about other things? We can have also other salts that could dissolve in water. Let's speak about AgBr. Let's speak about FeOH2. And let's speak about um, AlOH3. Now I want you to notice the difference between dissolving these three salts in water. Now AgBr, when it is dissolved in water, what does it dissociate into? Simply it dissociates from here, Ag plus and Br minus. All these three salts are slightly soluble. Now in this lesson we will speak only about slightly soluble salts. يعني part will dissolve and part will stay in the bottom. Now how do I write this? I say AgBr solid, double arrow because part will dissolve and part will not. Ag plus aqueous and Br minus aqueous. Now, what about FeOH2? Now, regarding the FeOH2, when FeOH2 dissociates in water, what does it dissociate into? Okay, so FeOH2, when it dissociates from here, it will divide, it will give you Fe and OH, and again OH, and part of it will be here. Now, how do I represent this in the reaction? I will say FeOH2 solid, double arrow, because part will dissolve and part will not. It will give you Fe plus 2OH, because I have 2OH. اوكي طبعا هاي بتكون aqueous وهاي aqueous. طيب now what about this one? يلا dissociate this one. It will dissociate from here. Same story. When I put it in water, part will not dissolve, and this one will dissociate into Al and OH and OH and OH. So I will say Al OH3 solid. This will give you Al plus 3OH, and this is aqueous, and this is aqueous. Okay, طيب بما إنه we have equilibrium, can we write KSP, which is the same like KEQ or KSP for each one? Let's start with the first one. The first one, KSP, is equal to P over R, which is equal to products AG darb BR over 1 or over nothing, because this is solid. Now here, KSP will be also P over R. I will say Fe darb OH. This coefficient will be power over 1 also, because this is solid. And here KSP will be Al darb OH, and this 3 will be power. Okay, notice that the KSP expression is not always the same. Here it's Ag darb Br. Here it's Fe darb OH2. Where did this 2 come from? It's from here. Okay, here Al darb OH3. This 3 becomes power because I have 3 OH. Now let's speak about the solubility. The solubility, which is S. Now if I put from AgBr 1 mole, how many AGs I will get and how many BRs I will get. If I have 1 AgBr, I will divide it. I will get 1 Ag and 1 Br. Similarly, if I put 4 moles, I will get 4 Ag and 4 Br. Okay? Now, if I say I want to put S moles, I will get SAG and SBr. Now, why did I choose the letter S? Because S means solubility, because I am doing dissolving. Okay, now if this is S, this one will be S, and this one will be S. So what about here? If I take S from this, Fe will be S and OH will be 2S. Okay, so I will say if this is S, this will be S, and this one will be 2 darb S. Okay, similarly here, if this is S, this one will be S, and this one will be 3S. Okay, so far good. Now let's replace Ag with S. Dar Br is S. S times S, this is equal to S squared. Now how do I benefit from this? لو I gave you the value of KSP in numbers, you can calculate S. يعني مثلا لو I say for you KSP is 1.6 times 10 to the minus 5, S will be square root of 1.6 times 10 to the minus 5. Okay, so you can calculate the solubility. Now let's see here. Here KSP is equal to Fe is S, darb OH is 2S. طبعا square. Be careful. Now the 2 appears twice. Here once and as a power. Okay, now the 2 is for this and for this. 2 square, this one will be S. This one, 2 square will be 4. This will be S square. S square and S power 1, this will give you 4S power 3. Now again, if I give you the KSP, you can find S, divide by 4, and then you take the third root. Okay, now this one, Al is S, OH is the 3S, power 3. So I will say S, now 3 power 3 and S power 3. 3 power 3 is 27. 3 times 3 times 3, s power 3. So I will get 27 s power 4. Again, if I have the KSP, I can calculate S. I want you to be very careful. Not always KSP is S squared. Sometimes KSP is S squared. Sometimes KSP is 4S cubed. KSP is 27S power 4. It depends on the solid I am dissolving. Okay? طيب, now let's do practice. Okay. We have KSP and I want to know the KSP expression. AgCl divided into two parts. What does it divide into? Ag and Cl. So KSP will be equal to Ag plus Cl, and these two are aqueous. So it will be P over R. So it will be Ag ضرب Cl over 1 طبعا. So the answer is A. Again, I repeat, if you don't know the charges, it's okay. You have just to worry about the elements. Now, CuH2, be careful. CuOH2, when it dissociates from here, it will give you Cu plus 2OH. So the KSP will be products over reactants. So it will be Cu times OH, and this 2 will be squared. So the answer is this. Okay, now another one. I want you to pause the video and to think of this. FeOH3 dissociated from here. Okay, this will give you Fe plus 3OH. So the KSP will be P over R Fe ضرب OH power 3. طبعا over 1, which is over nothing. FeOH power 3. So this is the answer. Now, which of the following is the least soluble at 25 degrees Celsius? This means it have the least S. Now here, if I want to calculate S for this, dissociate this salt. It will be CaSO4. So the KSP here in this case will be S times S. Okay, here it will be S times 2S. Here it will be S times S. I want to tell you something. Some common mistakes the students do is that they think CaSO4, when it dissociates, it will give you Ca plus S plus O4. This is very wrong. Usually you dissociate it into two parts only. It cannot dissociate into three parts. Now, another common mistake, they say CaSO4, when it dissociates, it will give you Ca plus 4SO. Now, this is again wrong. Because when you say 4SO means the S is 4 and the O is 4. بينما هي ال S is 1 and the O is 4. Okay, so when the CaSO4 dissociates, simply you write Ca and SO4. So you will say CaSO4 dissociated from here. It will give you Ca plus SO4. So if this is S, this one will be S, this one will be S. So the KSP will be S ضرب S, which is S squared. Now, which one will have the least solubility? I think it will be ZNS. If you want to calculate the S in each case, you can. Here S, KSP is equal to S squared. Put KSP here and find S. Here, okay, you have the PbF2. This one, it dissociates into Pb plus 2F. So this is S, this is 2S, and the KSP is S ضرب 2S squared. So this one will be 4S cubed. Also here you can say KSP is equal to 4S cubed. You put the value of KSP and find S. This one is the same like this one, S ضرب S. So here KSP is equal to S squared. And this one also same like this one. So KSP is equal to S squared. In each case, you can find S and you can compare it, but the smallest one will be this one. Okay, now next. Now this question says the solubility product constant KSP is 1.84. So we have BaF2 and the KSP is equal to 1.84 times 10 to the minus 7. Calculate the solubility. So he wants S equals how much? Okay, as we know from before, step 1, you dissociate this. So BaF2 dissociates into, divided from here, this will give you Ba and 2F. طبعا solid, aqueous, aqueous. Now, second step, you write the S's. This one is S, solubility, this one is S, and this one is 2S. Now, the third thing, you write the KSP, P over R. Okay, what are the products? Ba, 2F becomes F square. Okay, now the Ba is S, F square is 2S square. Now this is equal to 1.84 ضرب 10 to the minus 7. Put it in the calculator and solve for S. Let me check if I have the answer. Okay, here S will be 3.5 ضرب 10 to the minus 3. 3.58 ضرب 10 to the minus 3. Pause the video and answer this question again by yourselves. Erase. Pause the video and answer the question by yourselves. Remember the steps. First step, you dissociate it. Second step, we write the S's. Third step, we write the KSP expression. Okay, now another question. Okay, another question. We have this equation. Is this equilibrium homogeneous or heterogeneous? Now this one, all gases, this is homogeneous. When it is homogeneous, this means that nothing should be cancelled. Now Kp, or why do we say P? Now this is pressure, don't worry about it. You can say Keq is equal to products over reactants. What are the products? NO power 4 over reactants, N2O square times O2. Okay, now you put the pressures. Whether you deal with pressures or whether you deal with concentrations, it is the same, no difference. So here NO4, which is 0.2 power 4 over N2O, this is 2 squared, times O2, this is 4, and then you find the value of KEQ. I think the value will be 1 times 10 to the minus 4. Okay, now another question for the reaction. X plus Y solid in equilibrium with 2Z. X is 1.2, Z is 3.6. Calculate K. I'll give you 2 minutes. Pause the video and answer the question. Okay, and you find the value of K. Here K will be 10.8. I want you to remember one thing. We said before, if K is more than 1, this means products are more than reactants. This means that products are favored. And this means that the reaction likes to go in the forward direction. Okay, remember, if K is more than 1, this is the case. Type. Okay, now another question. Now these are all the solubilities. We spoke about them before. We said AgCl dissociates into Ag and Cl. So S times SS square. PbCl2, this will dissociate into Pb and 2Cl. S times 2S. So the KSP will be 4S cubed. Now AlOH3 will dissociate into Al and 3OH. Okay, now Ba2S3. What do you think Ba2S3 will dissociate into? Can you try it by yourselves? Okay, Ba2S3. This will give you 2Ba and 3S. Okay, if this is S, this one will be 2S and this one will be 3S. Now the KSP will be Ba square times S power 3, which is 2S squared ضرب 3S power 3, and it will be 108 S power 5. If I give you the KSP, you can calculate S. Okay, now these are set of KSP values. طبعا you cannot memorize them and you will not be asked to memorize them, but these are the KSP values. Which of the following is the least soluble? This is similar to the one that we just solved. You can see the KSP values and calculate the solubility. The answer will be Z and S. Okay, we have FeOH2 is sparingly soluble, يعني slightly soluble. Okay. KSP is 7.9 dark 10 to the minus 16. First of all, you need to write the solubility product for FeOH2. طبعا when FeOH2 dissociates, what does it dissociate into? Fe plus 2OH. So the KSP equal, if this is S, this one is S, this one is 2S. Okay, Fe ضرب OH square over 1, which is S, 2S square over 1. So the answer will be 4S cubed. Now calculate the solubility. They want S. Okay, we have the KSP 7.9 dark 10 to the minus 16 equal 4S cubed. Now put it in the calculator and solve for S. I think S will be 5.8 dark 10 to the minus 6. Now calculate the concentration of OH. OH is 2S. Okay, so you multiply this number by 2, 5.8 or 10 to the minus 6. Okay, another question. Okay, you have this equation. Is this reaction homogeneous or heterogeneous? طبعا it is homogeneous because all of them are gases. Nobody will be cancelled. How do you write the KEQ expression? Products over reactants. Okay, so I will say NO2Cl square over NO2 square ضرب Cl2. Okay, and you put the values. NO2Cl is 0.5 square over 0.25 square ضرب 0.32. I think the answer will be 12.5. Okay. Now, the last thing you need to know in term 1 is what predict whether a precipitate will form. In this question, I will be mixing two chemicals in one container. For example, I will be mixing NaCl 0.1 molar with AgNO3 0.1 molar. And the question, will a precipitate form? Will there be these dots or not? Will a solid form in the bottom or not? Of AgCl, and they will give you the KSP of AgCl مثلا 1.8 ضرب 10 to the minus 5. Okay, now the question is, will a precipitate form? I don't know whether a solid will form here or not. Step number 1, same like we did before. I will take the AgCl solid. Okay, I will dissociate it into two parts. It will be Ag plus Cl. Be careful. Now I will not write SSS because they are not asking for the solubility. Okay. Now I will write KSP is equal to P over R, which is equal to Ag times Cl over 1 because this is solid. But here, because I'm not sure about this AgCl, whether it will form or not, I will change the name of KSP and I will call it QSP. Question, I'm not sure. This is QSP. I am not sure about if a precipitate will form. Okay, same rules like KSP, products over reactants. If there is a coefficient, you make it power, but only I change its name. Now, in order to calculate QSP, I need to know how much is Ag and how much is Cl. Where can I get these two numbers from? لاحظوا إنه Ag came from here, so its concentration is 0.1. And Cl came from here. Its concentration is 0.1 over 1. So this will give us 0.01. Now, شو بستفيد أنا إذا حسبت ال QSP? I will compare QSP to to KSP. If QSP was more than KSP, this means yes, a solid will form. If QSP was less than or equal to KSP, this means no precipitate or no solid will form. Okay, so first step, I will calculate QSP and then I will compare it to KSP. Now let's look here. Here the QSP is 0.01, KSP is 1.8 ضرب 10 to the minus 5. Is QSP more than KSP ولا less than? طبعا QSP is more than KSP, so this means yes, a solid will form. Okay, so again I will repeat. I mix two chemicals together and I want to know if a solid will form or not. So I will take the solid, I will dissociate it, I will write the KSP, but I will not name it KSP, I will name it QSP because question, I'm not sure if this will form or not. Okay, and then I will calculate it and I will compare it to the KSP given. If it was more means yes, if it was less or equal means no precipitate will form. Okay, let's do question on this. The KSP of calcium carbonate is 4.5 ضرب 10 to the minus 3 and we have the concentrations. Question 1, write the KSP expression. لاحظوا when we say expression means in letters. First of all, like we did before, CaCO3 dissociates. What does it give? Ca plus CO3. Now the KSP will be products over reactants. The products are Ca ضرب CO3 over the reactant is 1 over nothing. Okay, طيب. Now, predict whether a precipitate or not will form and show all your work. Now, a precipitate of CaCO3, I will call it QSP, not KSP, because I am not sure whether it will form or not. Okay, it's equal to Ca ضرب CO3. Now the Ca is 0.05. CO3 is also 0.05. Now QSP will be 2.5 ضرب 10 to the minus 3. Now I will compare it to KSP. Who is more? شوفوا ال KSP 4.5 ضرب 10 to the minus 9 وال QSP 2.5 ضرب 10 to the minus 3. طبعا هاي أكبر. This means yes, a precipitate will form. Okay, predict whether a precipitate or will form or not. Yes, it will form. Okay, another question. Okay, precipitate will form. Now, QSP is less than KSP, precipitate will not form. QSP more than KSP, a precipitate will form if they are equal, solution is saturated and no precipitate will form. Okay, just to combine them, is there a QSP more? Means yes. Is that a QSP is less than or equal to KSP, this means no precipitate will form. طيب يلا, I want you to try this question. عندنا Ag2CrO4. Okay, عندنا Ag2CrO4. When this one dissociates from here, what does it give you? طبعا it will give us Ag2CrO4. When this one dissociates, it will give you 2Ag plus CrO4. Okay, now the KSP will be products over reactants, Ag squared ضرب CrO4. Calculate QSP. طبعا QSP, which I'm not sure about it, is equal to Ag squared ضرب CrO4. Now Ag is 1.5 ضرب 10 to the minus 2 squared ضرب 7.5 ضرب 10 to the minus 3. You calculate QSP. Will a precipitate form? Let me see how much is QSP. QSP will be 1.6 times 10, 1.7 times 10 to the minus 6. Now I will compare QSP to KSP. Okay, KSP is 1.2 ضرب 10 to the minus 12, and this one is 1.7 ضرب 10 to the minus 6. So QSP is more than KSP. This means yes, a precipitate will form. Okay, this is the last thing in your term one. I hope my videos were clear enough to help you understand and to help you do well in your exams. Please leave me a message if you feel there is something I can improve. Hopefully, I will see you in term two, and I will be doing also the same videos for you in term two to help you. Wishing you all the best, and I wish you all you score. I wish you all you score 100 over 100 in your exams. Best of luck for all the seniors of 2023. With my best wishes, my name is Mrs. Hanan and I am from TBMEC campus. I'm from Al Ain Al Kharir campus. Please leave me messages if you feel there is anything I can help you with in term two. And if you need any extra practice sheet, send me also messages and leave your emails. I will be sharing with you past papers and past questions. All the best. Love you.